the final transformations that we're going to work on in this particular lesson are what we call compression and stretch transformations. Now, in geometry, you may have heard of a term called a dilation or something called a scale factor when you did similar polygons. Compression and stretching a function in algebra is very similar to a scale factor or dilating the function. Basically, what's going to happen is the value that we're going to take is going to be multiplied to the function. It's going to create this kind of this lengthening or shortening of the given function. And so we can have vertical compression and stretch. We can also have horizontal vertical and stretch. For right now, we're just going to focus on the vertical compression and stretch, and you can see that through the definition here and through the given graphic example that when we multiply a value larger than 1, you kind of get this lengthening or this stretching of the function. And so you can see the red graph is representing that, with the blue graph being the original function. Now if we were to multiply it by some fraction between 0 and 1, it would actually compress it a little closer to the x-axis there and kind of shrink it in a little bit, and that's represented by the actual green graph. And so you can see what a multiple simply does to a given function. So and you can see in the equation y equals a times f of x that the a value is being multiplied times the function, and it acts as that scale factor. So just keep that in mind, a scale factor or a multiple. Now, that is pretty much all compression and stretch is. We will work more specifically on the different types of vertical stretches and vertical compressions versus horizontal stretch and compression as we get into each individual parent function. It may take a little bit of individual work for you to have a clear understanding of what it does to each individual function. However, here in sample problem number 3, we just have a basic function. And so what I would like you to do, just in case you don't understand what this problem is asking, remember f of x is just simply representative of y. Okay, and so we're going to graph these points x and y, or x and f of x, and then basically connect the dots with them. Then we're going to see how g of x relates, and so basically g of x has a multiple of 3 times f of x. So this is going to vertically stretch our original graph. So what I want you to do is to go ahead and fill in the remainder of the table. Use the x value for both f of x and g of x and see how it stretches. So go ahead and take a second to see if you can get a clear picture of the stretch. If you do this correctly, you'll pretty much know you did it correctly when you finish. So go ahead and pause the video and work that, and then come back and see the solution. Okay, so I'm going to start by actually just focusing in on this part of the table, x and f of x. These are points. So I'm going to say -5, +2, -2, +2, 0 and -3, 3, 1, and 5, and -2. So basically all I want you to do is connect the dots with those. So I'm going to just simply, as best I can, connect the dots. Okay, so now I'm going to take my final f of x value and I'm going to multiply that value by 3. So I'm actually multiplying the output or the whole function by 3. So I'm going to say 3 times 2 is 6, 3 times -3 is -9, 3 times 1 is 3, and 3 times -2 is -6. Now I'm going to match up these x values with g of x, which is kind of our output values with our new multiple. So g of x is also now, if you think about it this way, y is equaling to f of x in this first function, but in our second function y is equaling to g of x, and we're using g of x and f of x to basically define two separate functions, but the x values are going to be the same accordingly. That's what the x in g of x and the x in f of x is telling us, that we're using those same x values here. So let's take a look. So I'm going to say negative 5, 6. So negative 5, I'm going to go up 6. And then I'm going to go negative 2 and a positive 6. Now I'm going to go 0 and negative 9, which is, well, it's way down here. It's below where our graph gives us. Then I'm going to do 3, 3. And then lastly 5, negative 6. So that's kind of down here. And then I'm going to connect those dots. And what you can see there is we have a very, very similar looking graph that looks like if you just grabbed it on both ends and pulled it away from the x-axis, you're stretching it out away from the x-axis. And so that is a vertical stretch. And we've multiplied all of the original values in the first function by 3, thus giving us a scaling of 3 on there. So that's a good introduction to compression and stretch. This will be something that we're going to work with all year, and if it's not clear the first time you see it, that's okay. The more you work with it, the better and better it gets. So if you have any questions, be sure to ask questions in class.